Okay, now we're going to talk about arcs and chords. So remember, a chord is any line that goes from one endpoint of a circle to the other endpoint. So they can be anywhere. Diameter is probably the most recognized one, but chords can be anywhere as long as it touches one end to the other end is touching both edges of the circle. All right, so we have this theorem that tells us that if we've got these, if the chords are the same length, and remember we do the little hashtag if they're the same length. So like AB is the same length as CD. Well, this theorem tells us then that this arc that connects the two has to also be the same if the chords are the same length. So if the chords are the same length, then the arc is the same measurement or the same length, okay? So our first question in the example says to which two chords are congruent. Well, we know AB is going to be congruent to CD. Which two arcs are congruent? Well, they're the same ones, but we just put an arc over them. Are congruent to CD. So what are the measure of those arcs? Okay, well, if they're the same, we know that the whole circle is 360. So we're going to subtract out the 220 and subtract out the 20 degrees. So that gives us 120, and it's going to be divided by the two arcs. So then, therefore, each arc is 60 degrees. So this one is 60, this one is 60, and 220 and 20, and that should add up to be the 360. Okay, so that's our rule, sort of our theorem for this information today. Okay, so let's read the instructions and make sure that when we do that, we always go in label. So if PS is 12, so P to S, it's from here to here. This whole thing is 12. And T to R is 15. So this one is 15. Find Q to R. So it wants us to find this measure. Well, we know that this arc is 70 degrees. So let's see. The arc that goes from R to T is 60 plus 20. So that's 80 degrees. So he's not the same. But what about the arc that goes from P to S? Here, it's 50 plus 20. So that whole arc is 70 degrees. So if this arc is 70 and this arc is 70, then those chords have to be the same distance. And we know this chord is 12, so therefore R to Q or Q to R is also 12. Okay, let's go to our next example. It says to find HI. Okay, so let's start filling in what we know. Here's our H to I, and we're going to see what is that measurement. Well, we've got every measurement except for the arc from H to I, and so let's see, what's 360? It's the total of any circle, minus the 78 degrees, minus the 91 degrees, minus the 113 degrees. What does that give us? That's 78. 78 degrees. So the arc from H to I is 78 degrees, but it's asking for the length of this. Well, we know that if the arc measurement is the same, then the chord also has to be the same. So we've got a 78 degree here with this chord being 9, so therefore H to I, that chord also has to be 9. So the length of the chord, if they're the same, then the measures are the same. The arc length measure is also the same. So, and that's just going to go back and forth on those. So Okay, our next theorem tells us if we're in a circle and we've got a diameter or a radius, remember that's from the center out to the edge, if it's perpendicular to a chord, and remember that word perpendicular means it creates a 90-degree angle. So if we're told that they're perpendicular, we know that that's automatically going to be a 90-degree angle. Then it's a bisector of the chord and its arc. So that means if it's a bisector, then this measure here is going to be the same as this measure here. From E to C to E to B would always be the same. Okay, remember there's some of those terms that we learned at the beginning of the semester. All right, so in example 4, it's telling us that this A to D, which is a radius, okay, is perpendicular, that's what that sign means, remember, to BC. So we know that these are all going to create 90-degree angles here, okay? And the radius is 13. Well, my radius is from A to D, so we're going to go ahead and mark that as 13. So it's asking us to find the following. It says A to E is 12. I missed that part, okay? So if this is 12, the whole radius is 13, then we know E to D has to be 1, okay? And if we know, let's see, remember, we know any radius is 13. So that's going to be 13 here. Remember now, look, we've created a 90-degree triangle. So we could use a squared plus b squared is equal to c squared. Remember, A to E is 12. The radius here on the outside going to the C, which I didn't draw that very well. Let me see if I can do that a little bit better. So A to E is 12. Then we can draw any radius, so A to C is 13. So we can say 12 squared plus that C to E, we'll call that our B squared, is equal to 13 squared. So that 13, that would be our hypotenuse. So if we go to our calculators and we say 13 squared minus that 12 squared, so that means our B squared is equal to 25. And remember, we find the square root of that. So B is equal to 5, which means C to E then is 5. Well, remember, if it's a bisector, that A to D is a bisector, so E to B then is also 5. All right, so let's go look and see what some of the questions ask. It says, what is E to D? Well, E to D is 1. Already figured that one out. What is A to C? Well, A to C is just another radius, so any radius is 13. A to B, well, A to B, that would also be a radius, so that's 13. E to B, we found that is 5. E to C is also 5, and then B to C, the whole thing, would be 5 plus 5, which is 10. So these are just fun puzzles like we've talked about before in class. Okay, so example 5. If the measure of C going through F to B is 220 degrees. Okay, find the following. All right, so we've got 360 is the whole thing minus the 220. So what does that give us? 140. So 140 degrees. So from here all the way over to C then has got to be the 140 degrees. Well, this is telling us that it is a perpendicular bisector from A to D is bisecting this line C to B. So that means C to E is equal to E to B. So we know if the whole thing is 140, then each one of those has to be 70 degrees. Okay, Well, let's see if we can answer some of our questions just based on that. We don't know any of the lengths of any of these lines right now, and we'll see if we need to know any of them. The measure of C to B is that whole thing, so that's 140 degrees. CA, the measure of angle CAB, then remember those central angles, as long as it touches that center, is the same as the arc measure, so that would also be 140 degrees. The measure of angle BAD, well, we know that A to D is a bisector from those two, so we know that's got to be 70 degrees. It's going to be half of that. And measure of the arc C to D is also 70 degrees. Okay, so let's look at another example. Let's just start working on figuring out our puzzle here. In circle A, S to Q is 12. So we know from S to Q here is 12. This is a perpendicular bisector, so we know this has to be 6 and this has to be 6, making the whole length 12, because that means that they're the same, right? 6 and 6. A to T is 8. So just A to T is 8. It wants us to find A to R. Okay, so let's see. A to R is a radius. Okay, it goes from the center out to an edge. So it should be the same as A to S. So A to S is also a radius. So we can conclude that if we could find A to S, we know that that's equal to A to R. Well, we can find A to S because we've created a right triangle and we've got 2 of the leg lengths. So we can say 8 squared plus 6 squared is equal to C squared, or that A to S and A to S. So 8 squared plus 6 squared is 100, so C squared is equal to 100, so C is the square root of 100, which is 10. Well, if A to S is 10, then A to R is also 10. All right, let's look at example 7. Using the diagram below, find our indicated values. Okay, well, we've got a 90-degree angle right here. We've got a 60-degree angle there, which means this creates a 30, 60, 90 triangle. So that rule is, remember, this is 2x, this is x, and this is x square roots of 3, or our 90 degrees. Well, if 2x is equal to 6, we divide both sides by 2, so x is 3. Which means this side is 3, and A to D would be 3 square roots of 3. So, let's see. Our first question is A to D, 3 square roots of 3. C to D is 3, and the measure of angle of arc A to B would be, well, let's see, this one, let me go to a different color. If this one is 60 degrees, then we know from here to here is also 60 degrees. Well, this is going to be another radius out to that, and since it's a bisector, we know this angle also has to be 60 degrees, so that has to be 60 degrees too from that portion. So from A to B would be the 60 plus 60, which is 120 degrees. All right, now we're going to find values of x and y here in example 8. Okay, so This theorem tells us two chords are congruent if they are equal distance from the center. Well, this chord is telling us it's equal distance. These two lines from the center are the same, so therefore those chords have to be the same length. Well, remember, this is a bisector, so if this side is 8, then your other side also has to be 8. So x, therefore, is 8. Well, it's wanting y, which is taking us all the way across. We know that these two chords have to be the same length, so it's going to be 8 plus 8, which is 16. Okay, example 9. Circle O, if we have F to L is 3, and G to O is 5. Well, if F to L is 3, we also know that L to G is also 3. O to P is 4. Find H to J. Okay, so we can find out if these two triangles, if we know based on this rule, if this length from O to L is equal to O to P, then these two chords would be the same length, this chord and this chord. And we know this chord total is 6, because 3 plus 3. Okay, so we can use a squared plus b squared is equal to c squared, or that is a perfect 3, 4, 5 triangle, so we know then that this would be 4, which the other side, so L to O is 4, so O to P is 4, so they are the same distance from each other, so therefore H to J has to equal F to G. They have to be the same length. And if F to G was 6, then H to J is also 6. Okay, I know some of this might be a little confusing, but I have total confidence you guys can get it. Maybe you just need to watch the video a couple of times. All right, and really understand those theorems.